Global Defense Zone Intro. If you enjoy high-quality defense analysis and frontline military storytelling, hit like, subscribe, and share this video now to support the channel and never miss our exclusive deep dives. Imagine, for a moment, a dawn sky split by a silhouette unlike any the world has seen before. A tailless, lambda-winged predator sliding through the clouds with a menace that seems almost cinematic, an aircraft the size and shape of which defies the familiar lines of Western fighters, a machine built not simply to fight but to dominate, to rewrite the rules of air combat. This is the story of China's J-50, a shadowy leviathan of stealth and speed that, according to leaked images and breathless briefings, has stepped out from the realm of rumor into the daylight of reality, and the consequences ripple across every Air Force planning for the next decade. In this video we bring you a dramatic, unblinking narrative of the J-50 as if it were already a fully operational game-changer, a story of how an emergent Chinese air dominance platform could alter the strategic balance, how its shape, sensors, propulsion, and doctrine may work together to create a new generation of aerial warfare, and why every military professional and enthusiast should watch closely as history seems to pivot toward a new horizon. From the first flicker of leaked imagery that sent satellite analysts and aviation obsessives into feverish study, the J-50 has been photographed and discussed in a way that no mere prototype usually is. Clear shots of a tailless, cranked aero airframe with articulating or swiveling wingtips, a long blended fuselage suggestive of internal weapons bays, twin engines with serrated nozzles and apparent thrust vectoring, and a cockpit that looks as if it belongs to a predator rather than a conventional fighter. These design cues whisper a bold intent: low observability married to aerodynamic efficiency, a spacious internal volume for advanced sensors and weapons, and control surfaces engineered for agility even at high subsonic and transonic regimes. Picture the J-50 slipping past long-range radars because of a combination of shaping, chins, and radar-absorbent materials, then using a potent sensor fusion suite to see beyond the horizon. Imagine it not only surviving in a contested electromagnetic environment but thriving there, with onboard computing and networking that binds the jet into a system of systems where data links, off-board sensors, and autonomous support assets act as extensions of its situational awareness. In the dramatized world we describe here, the J-50 is built around an integrated sensor network, advanced AESA radars with low probability of intercept modes, distributed aperture sensors, and long-range electronic warfare payloads, which together provide a layered picture of the battle space, enabling the pilot to make decisions faster than any opponent. Visualize a mission. At high altitude, a formation of J-50s threads into the edge of a contested theater, their emissions carefully controlled, each jet sharing a common tactical picture with unmanned wingmen and high-altitude ISR platforms. When the enemy's early warning net tries to track, the J-50s use deception, coordinated low observable ingress, and timing to approach weapons release ranges undetected, then burst into action with internal air-to-air missiles launched from clean bays, minimizing radar cross-section penalties and maximizing surprise. The implications are profound. A fighter that can control both the physical and informational layers of conflict forces adversaries to rethink air defense geometry, intercept doctrine, and even rules of engagement. Now imagine the propulsion and maneuvering. Thrust vectoring nozzles giving the J-50 a turning envelope more reminiscent of an air superiority demon than a heavy strike jet, allowing it to combine energy maneuverability with stealth tactics, brutal in a dogfight yet lethal beyond visual range. Couple that with reports of swiveling wingtip control surfaces and lambda wing design that favor efficiency at high speeds and stability at transonic conditions, and you have a platform engineered to survive in contested airspace while retaining the fight ability to defeat whatever is thrown against it. Onboard avionics are not an afterthought. In our narrative, the J-50 integrates AI-assisted sensor fusion and predictive threat recognition, algorithms that suggest maneuvers, select the most effective sensor modes, and even coordinate complex missile engagements across multiple aircraft and unmanned platforms. This level of automation reduces pilot workload and compresses the OODA loop, observe, orient, decide, act, to speeds human reflexes alone cannot match. For the outside world, the specter of the J-50 is not limited to raw performance metrics. it is the doctrine it enables. Consider a Chinese air doctrine that uses J-50 squadrons as mobile nodes of denial and control, paired with long-range standoff weapons, swarms of loyal unmanned systems, and ground-based networked sensors. The J-50 becomes a keystone in layered anti-access/area denial (A2/AD) strategies. In such a construct, carrier strike groups, forward bases, and even air corridors could be contested at unprecedented ranges, forcing adversaries to adapt or cede control. The political fallout would be seismic. Alliances would reevaluate basing, procurement, and interoperability requirements. Air forces might accelerate development of counter-stealth sensors and longer-range interceptors, while navies and ground forces would hasten investment in resilient integrated air defense systems. But what about the human side? The pilots, the tactics, the training? In our narrative, China invests heavily in developing a cadre of J-50 pilots trained not just to fly but to command a networked fight, masters of cooperative engagement, able to direct unmanned wingmen and utilize off-board sensors to create shot opportunities that exploit fleeting windows of vulnerability. These pilots practice complex kill chains where kinetic and non-kinetic fires are orchestrated to disable adversary sensors, open corridors for follow-on strikes, and then vanish back into the electromagnetic fog. On the technical front, weapons integration is critical. Internal bays accommodate a range of modern missiles, beyond just dogfight-class short-range weapons. Think medium and even longer-range active radar and IR-guided missiles capable of engaging stealthy targets, and standoff munitions for surface strikes, enabling a single airframe type to exert influence across multiple mission sets. Logistics and sustainment cannot be ignored either. To field a fleet of such advanced fighters, China would need supply chains for advanced composites, high-temperature alloys, and next-generation engine maintenance. Yet the scale and speed of recent Chinese aerospace projects suggest a state ready to marshal industry and capital to turn prototypes into operational squadrons. Economically and strategically, the J-50 narrative becomes a lever for diplomacy and deterrence. Just the perception of a fielded, sixth-generation capable platform shapes bargaining positions and compels rivals to scramble for parity. Imagine U.S. and Allied reaction. A renewed push for advanced sensor architectures that combine low-frequency radars, infrared search and track networks, and space-based sensors to spot and track low-observable platforms. A surge in investment in distributed, resilient ISR, and acceleration of programs for loyal unmanned combat aerial vehicles, UCAVs, that can complement manned fighters in contested environments. The race would not be purely technological. It would also be intellectual, testing doctrines, training philosophies, and coalition interoperability. The psychological effect on pilots and commanders is not trivial. Adversary forces facing a credible J-50 fleet may operate with more caution, altering patrol patterns, dispersing assets, or changing rules of engagement to avoid catastrophic surprise. This attrition by caution, where the mere threat of a superior platform imposes costs and reduces operational tempo, is as valuable as any missile or radar. In our dramatized world, the J-50 also acts as a catalyst for novel countermeasures. Directed energy weapons, quantum-resistant data links, and hypersonic interceptors are no longer sci-fi priorities but operational necessities on hurried procurement lists. But every aircraft has vulnerabilities and every advantage invites countermeasures. As powerful as the J-50 narrative is, its stealth depends on discipline, emission control, secure logistics, and the continuing integrity of materials and manufacturing processes. Its networked edge requires data links and off-board sensors that, if degraded or jammed, could blunt its reach. And sophisticated engines and thrust vectoring demand sustainment regimes that are complex and costly. In theaters where peer competitors have invested in passive detection methods, multi-static radar networks, passive RF triangulation, and optical/IR tracking, the J-50's cloak could be frayed. This is the dialectic of modern air power, a constant cycle of innovation and countermeasure, attack and defense. Our narrative must also consider escalation dynamics. When one state fields a platform perceived to surpass existing defenses, adversaries may respond asymmetrically, increasing ISR flights, deploying electronic attack assets, or probing political edges in ways that risk miscalculation. How nations manage signaling around such a capability could determine whether it stabilizes as a credible deterrent or destabilizes through misunderstandings and accidents. On the theater level, Asia's security environment is particularly sensitive. Proximity of major naval choke points, dense concentrations of military infrastructure, and overlapping claims raise the stakes. The J-50, in our story, becomes a tool for both power projection and coercion, capable of denying access to specific corridors or of supporting rapid strikes to neutralize critical assets in a crisis. From a historical perspective, the J-50 fits into a long lineage of leap-ahead weapons that have shifted strategic balances. Think of the introduction of radar, jet propulsion, or carrier aviation, but its distinctiveness lies in its fusion of stealth, autonomy, and networked operations. It is not merely a platform but an architecture, an attempt to blend human decision-making with machine speed and precision. For analysts and policymakers, the J-50 narrative is a warning to invest not only in platforms but in doctrine, alliances, and resilience. For hobbyists and enthusiasts, it is a technical marvel to dissect, from its engine plumes to its wingtip actuators. And for pilots, it represents both a professional challenge and a new frontier of aerial combat. Yet even as we dramatize the J-50's capabilities, the broader lesson is strategic. States that master the integration of sensors, weapons, and networks will hold disproportionate advantage in future conflicts, and the battlefield of tomorrow will be defined less by single platforms and more by the ecosystems that connect them. In closing, whether the J-50 becomes the symbol of a new era of Chinese air power or remains a prototype that spurred decades of innovation elsewhere, its appearance in the public eye has already altered calculations and accelerated programs worldwide. The existence of such a machine, real or rumored, prototype or production model, compresses timelines and forces decisions at the highest levels, making it one of the most consequential developments in modern military aviation. If you found this cinematic and analytical look at the J-50 compelling, remember to like, subscribe, and share this video, and stay tuned to Global Defense Zone for further in-depth coverage as more details emerge about next-generation fighters and the ways they reshape global security. Sources: recent open reporting and imagery analyses on the Shenyang J-50, also referred to as JXDS/JXD, provide the sightings, design details, and discussion that inspired this dramatized narrative.